In this class, now I am going to explain you proof of an inequality, and also I explain you some applications based on that inequality. So that is a very important and famous inequality in the calculus. So before going to learn proof of that inequality, now I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Now let us learn that proof of an inequality. If x belongs to 0 to 90 degrees or pi radians by 2, then sin x less than tan x. If x is lying between 0 to 90 degrees, then show that sin x less than tan x. Then show that sin x less than tan x. Okay. So to prove this inequality, here now I would like to use plane geometry concept. Okay. So here consider a circle of radius r units. See, this is the center of a circle. Now this is radius. Let us consider center of the circle be O, and draw the tangent at this point. So you will get like this. Let us say this is P, point of contact. Now connect O and this point. Let us say this point be some Q. Okay, students. Right. Now see, OP is radius of circle. Now here this OQ is intersecting this circle at a point. Let us say this point be A. Now connect A and P. Okay. So now drop a perpendicular from A to OP. Let us say this point be B. Okay. Now see, observe that figure carefully. Okay. See, consider angle POQ be, let angle POQ be small x. This is small x. You know the distance from O to A, small r, because radius of the circle. In that figure, O to P also, whose distance is small r. O to P is r because radius of the circle. Okay, students. Now after that, see, observe the figure carefully, in which you can say that area of triangle OPA is smaller than area of a sector OPA. This is one sector OPA. So area of sector OPA, area of a sector OPA is smaller than area of a triangle OPQ. Area of triangle OPQ. Okay, students. So here angle POQ we have taken as small x. Now observe carefully, once again I am explaining you here. Area of triangle OPA. See, observe the figure. This is smaller than area of the sector OPQ. This is the sector whose area is more than area of AOP triangle, and this sector area is smaller than area of OPQ. Okay. Right. Now find the area of OPA. Area of OPA. You know the formula to find the area of OPA. 1 by 2 base into height. Your base value O2P. How much is that length? Radius of the circle, small r. And here 1 by 2 base into height. Height is how much here? AB. Less than. Now area of sector OPA. You know area of the sector formula. A is equal to area of the sector. You read this formula. A is equal to LR by 2. LR by 2. Where L means length of the arc. R means radius of the sector. Okay. And you have one more relation. L is equal to R theta. R into theta means angle in a sector. That is here X. Rx. L is equal to R theta. You have one more relation in the sectors. But here R radius. X means angle in a sector. Now in the place of L, replace this Rx. So that you will get, if you write here, Rx into R square X by 2. Now you got area of the sector OPA. R square by 2 into X less than. Now area of OPA, this is one right angle triangle because you know radius is perpendicular to the tangent at its point of contact. Now 1 by 2. Base OP means radius no and height PQ. Till here you have understood. Okay. Now calculate AB length and calculate PQ length. To find this AB length, what is AB there? Height of OPA triangle. Here we have dropped AB perpendicular to OP. Okay. So to find this AB, now I would like to use this OBA triangle. OBA triangle. Right. Now from OBA triangle, from triangle OBA, define sin x. Now sin x equal to opposite is AB by hypotenuse is smaller, such that now AB is equal to R sin x you will get. AB equal to how much? R sin x. Okay. Now to find PQ, consider OPQ triangle. OPQ triangle. From this OPQ triangle, define tan x. Define tan x. From OPQ triangle, define tan x. Tan x means, okay, you know, opposite by adjacent. Opposite is PQ and adjacent is OP. OP that is nothing but small r. Now, such that PQ is equal to R tan x you will get. Okay. Now AB value R sin x. When you write replace AB by R sin x. So what do you get here? R square sin x by 2 less than R square by 2x less than your PQ value R tan x. When you write here R tan x, R into R square by 2 tan x. Okay. Now all these are positive quantities only because your x belongs to 0 to 90. 0 to 90. So all these are positive quantities. So I am cancelling this R square by 2 positive quantity from 3 terms. Can we cancel? Yes. R square by 2, R square by 2, R square by 2. After cancelling R square by 2 here, what is left? Sin x less than tan x. Okay. So if x belongs to 0 to 90, then sin x is less than tan x. Using this inequality, we are going to learn many more applications. So now let me explain you some applications based on this inequality. I hope you have understood this proof. Right. Let us go to the applications. Now see students, sin x less than tan x. Now divide these three terms with x. Okay, because x is a positive quantity. When you divide 3 with x, no changes will come in the inequality. Sin x by x less than 1 less than tan x by x. Now my question is, limit x approaches to 0, sin x by x equal to how much? If I ask this question, what you people have to say? Sin x by x, when x approaches to 0, so this function is going to be taken value 1, very close to 1 but not exactly 1, very close to 1, smaller than 1, like 0.999 it may be, but usually we write as 1. Limit x approaches to 0, sin x by x equal to how much? 1. Is it exactly 1? No, very close to 1. This value is smaller than 1, like 0.999. If x belongs to any value from 0 to 90, so sin x by x equal to how much? Very close to 1 from left side of 1, means almost 0.999, but usually we write 1. Okay, similarly, limit x approaches to 0, tan x by x equal to how much? It is going to be also 1. Is it exactly 1? No, more than 1. More than 1 means it may be 1.0001, very close to 1 from right side of 1, but we write 1. Okay, these two are standard limits. Remember, like a standard formula, but how that formulas have generated, here I am giving you proof for this. Limit x approaches to 0, sin x by x equal to 1. Limit x approaches to 0, tan x by x equal to 1. This is the reason behind it. But when you go to the competitive exam, so we say, so when here it is a rational function. In the numerator one function is there, trigonometric function, denominator algebraic function is there. When you write x directly 0 here, 0 by 0, it is attaining indeterminate form. In such case, we say to follow the L'Hospital rule. What is L'Hospital rule? So we do the differentiation of numerator so that you will get cos x, and we do the differentiation of denominator 1. After differentiation, put x equal 0. If you write put x equal 0 here, cos 0 becomes 1. And here also, if you want to answer this question by L'Hospital rule, tan x differentiation sec square x, by differentiation of denominator 1, put x 0, secant 0 becomes 1. You can answer like this also. Okay, right students. Now let us learn few more applications based on this inequality. See that limit x approaches to 0, sin x by root x square. Okay, now evaluate the limit of this function when x approaches to 0. Okay, how you have to say? Limit x approaches to 0, sin x. Now find the square root of denominator. If you find the square root of denominator, it is going to be mod x. Am I right students? Mod x. Okay, you know the definition of mod x. Mod x equal to x. If x is more than 0, it is going to be minus x. If x is less than 0. So now I am evaluating left hand limit for this. So while finding the left hand limit, we write like this: limit x approaches to 0 minus sin x by x. In the case of 0 minus, here it should be written as minus x. So here mod x definition, you know, mod x equal to minus x when x is less than 0. Here x is approaching 0. Here this is number line 0. X is approaching 0 from left side. Left side means our x value will be negative. Very close to 0 but smaller than 0. Smaller than 0 means negative values, no? So confirm that x value is negative. Negative means it should be written as minus x. Okay, write this minus outside. Minus limit x approaches to 0 minus sin x by x. Now just now we read it attains 1. Am I right, students? This value is going to be 1. Now write minus 1 into 1, which is equal to minus 1. Now left hand limit is minus 1. You got a real number, minus 1. You know limit of a function can be a real number. It attained a real number. Okay, fine. Keep it aside. Now go to the right hand limit. Right hand limit. Right hand limit. So for right hand limit, so you know limit x approaches to 0 plus. Now sin x by, so 0 plus means x is approaching 0 from right side of 0. Means it is positive. X value is positive. Whenever x value is positive, mod x is equal to x. Now you know it is going to be plus 1 as per the standard formula. Okay, left hand limit you got minus 1, right hand limit plus 1. Both are not equal, no. So here we observed that left hand limit is not equal to right hand limit. Both are defined. Both were given here real numbers. Okay, it is given minus 1, it is given plus 1. But both should be equal as per the existence of limit. So here we observed that both are not equal. Hence you can say that, so limit of this function does not exist. Limit of the given function, limit of the given function, limit of given function at x equal to 0 does not exist. Does not exist. Like this you people have to conclude for this question. Okay, I hope you have understood this. Now let us go to one more application. See this. Evaluate the limit of this function. Limit x approaches to 0. 100 into sin x. Step of 100 into sin x by x plus 99 into x by tan x, where this symbol represents GIF, greatest integer function. You know the meaning of this greatest integer function. Okay. Now, please answer to this question. Limit x approaches to 0. Step of 100 into sin x by x. 100 into sin x by x plus 99 into x by tan x, where this symbol represents GIF, greatest integer function. How do you answer to this question? You know student, just now we read this inequality. Sin x less than x less than tan x. First to prepare this. To prepare this, so take these two. Okay. Sin x less than x. Now divide both of them with x. Now sin x by x less than 1. Now both sides multiply with 100. If you multiply with 100, 100 into sin x by x less than 100. Now for this, take greatest integer. Apply greatest integer. Take the greatest integer of this. 100 into sin x by x. Actually it is saying that this value is very close to 100 from left side. It is smaller than 100 means how much it can be? Very close to 100. From left side means approximately it may be 99.999 something. But when you take whose greatest integer value, it becomes 99. Am I right? This value is smaller than 100. Smaller than 100 means 99.999. So if you apply this symbol for this, it will be 99. Okay? 99. Right. Now prepare the right hand side. This one. You got this value as 99. Now keep it aside. Now let us go to prepare this value. So for that, what do you do? What do you do? Now take this. Okay. X less than tan x. Okay. Right. Now what do you do? Divide both sides with x. So that here 1 less than tan x by x. Now reciprocal on both sides. When you take reciprocal on both sides, it is more than 1 no. When you take reciprocal, So here inequality sign will change. One is greater than x by tan x. X by tan x. Now before x by tan x 99 is there. Now multiply both sides with 99. 99 greater than 99x by tan x. Okay students. Now what it is saying? This result is smaller than 99. As per this inequality. Okay, how much is this? Smaller than 99. Smaller than 99 means it can be 98.9999 something. Very close to 99 from left side of 99 on the number line. So if you take greatest integer value for this, how much it can be? 99x by tan x. Okay, right. Now the greatest integer of this will be 98. How much is this? Smaller than 99 means it can be 98.999. If you take the greatest integer value for this, you will get 98. So plus here 98. Now add both of them. How much it can be? 197. Okay, 197. So this is our limit value of this function. When x approaches to 0, this function is going to be attain a value 197. Okay, like this we have many more applications based on this inequality sin x less than tan x in the calculus. In future classes I explain you many more applications based on this inequality. Thank you.